welcome again. I don't need to introduce myself again, I hope. So this is about the collaborative business process management specific enabler, or CBPM in brief. This is a platform for the semantically enhanced design and execution of business processes. And it is targeted at complex and or distributed organizations in the virtual factory domain, basically. Again, this is a concept which comes from the factories of the future. I hear a lot of noise in the background, so please, if you are not speaking, which you should not by now, please mute your mic. Thank you very much. Thank you. So it means that we are addressing some typical problems of big teams. And for this reason, this software, again, like FITMAN is entirely web-based, and you don't have to install anything locally. You can access it from anywhere. Now, the specific enabler is based on a generic enabler from Fireware, which is called Compel. Also, it is called the light semantic composition. Let's say that the light semantic composition is the generic term, why Compel is the name of the product. But this is not from engineering, it is from Atos, and this is the reason why I will leaving the floor in a short time to Joachim to make an in-depth presentation of Compel. What the CBPM is adding to Compel is basically the integration with corporate IT environment, the federation capabilities, and the integration with the corporate IT environments. But Compel by itself is something that is made for modeling business processing by composing existing services inside a graphical environment. So it's something that the non-technical user can use. And the non-technical user will be selecting web services from a catalog using a reference ontology as a blueprint. So you will have annotations on both the service tasks in the processes and on the web services in the catalog, and then you will do the matching to see which web services are actually matching the requirements of your process tasks, your abstract process tasks. And then you can also bind these process tasks to the web services for the execution of the process. Because as I mentioned before, this platform is also a business process execution platform. And this means that service tasks will have to be able to call web services in an automated way. This is something that is done in the background. Then in the design environment, you can assign responsibilities to the human tasks using either user roles or even user identities. Okay, and finally, you will have also a web-based user interface for completing the human tasks defined in your process, to monitor your process instances and to manage them. So the benefits of this software is that while the development of business processes using a formal notation requires usually a multidisciplinary teams, then you will need to cooperate at different levels. And the CBPM simplifies this because it allows for a clear separation of concerns. You will have business users on one side and technical users on the other, and they don't step on each other's toes, just to speak frankly. And And then you will have the user friendliness of a graphical-based user interface for modeling the processes, and of course the universal access, which comes from the web. And from the technology point of view, the engine and the design environment is a customization of the activity BPM platform. And this is enclosed inside a live-array portal server, exactly like the FITMAN CAM. We have a Sesame ontology server as well, and we have the same single sign-on system. So basically, what this means is that you may even use FITMAN CAM and FITMAN BPM together in the same federation, in the same enterprise environment, using one single sign-on service, one single security domain for both. The open standards that are used under the hood are the BPMN 2.0, meaning that all the processes that are defined with this tool can be also exported to some other environment because it is totally standard, and the RDF, the resource description framework for the semantic annotation of the services and the process tasks. This is an architectural overview where we see the Compel generic enabler, which is basically wrapped inside the web portal, which adds the federated single sign-on and some very basic web collaboration tools. What we see here is that through the use of federated single sign-on, in this case, as well as in the FITMAN case scenario, we can have corporate users that are able to access the platform without the need to replicate the credentials outside of the enterprise systems like Active Directory or LDAP. Provisioning the distribution of the software, this comes in a similar way as of FITMAN CAM in two flavors. We have a binary distribution, which is based on a virtual machine image, which is in both in a KVM version and in VirtualBox version, and we think we will put online together with FITMAN CAM a shared instance, so you can play with it without the need to install anything. So I think that we are over with my introduction. Just a last word about the licensing, but this is again an open source software, so no need to speak too long about this. I will leave the floor to Joachim, and also the screen, I suppose. I don't know, Joachim, if you have your own slides or you want me to flip through the. Yes?
We can continue with this if you want, if not, but at the end I need to have the control in order to show the live demo. So
okay,
maybe...
but you have the PowerPoint.
Yes, I have it, yes.
So I suggest that we switch the screens so that you can proceed with the live demo afterwards.
Okay.
Okay, I've changed the presenter to Joaquin now. Did get a message that you might need to download the desktop version.
Okay, let me check it. Pantalla 1, pantalla 2, pantalla. Now, let me know if you can see my screen.
Yes.
Okay, perfect. So I'm going to, okay, perfect. So let me introduce, I'm Joaquin Iranzo from Atos. I will present you the Compel generic enable. As Mauro has introduced, it is a generic enable that tries to cover the necessity of the definition of the business process in the scope of the business and technical approach. So what is the COMPEL motivation? As you know, when you try to define a business process, the life cycle that you need in order to introduce this or in order to define this business process, there are different roles involved in this life cycle. So one of the main problems that you can find to define this process is the gap that we have it between the business analyst and the service integrators. As you know, when the business analyst has a different scope, the business analyst have another knowledge, and the system integrators needs to be more concrete, more technical point of view. So at the end there is a gap between the two roles that we try to reduce in order to be close. We will see in the demo. So, well, as I have commented, we have a dispersed knowledge. There are two levels of knowledge. One is the business, this is a domain specific for business process and conceptualization. Another is a very technical point of view. What is exactly the protocol I need to call to this web service? What are exactly the attributes? Well, you see all, you know, what are the different technology. So this gap is sometimes can be a problem, and we try to reduce this gap. So there are another technical limitation. For example, how to discover or how to advertise the different web services that are in the internet and so on. It is limited. There are some repositories that you can use it. Also, this is obsolete, the service register as the UDDI. And we have incorporated new trends in order to, well, for example, to expose through REST and not only web service, the mashup, and so on. On the other side, the BPM, it's more related with the business process. So we have decided to use the standard BPM and not to use more the BPL, in the sense that we can transfer this BPM to the BPL, but at the end we think that it is more friendly for the business process and also for the technical people to use this BPM, because it's a standard graphical notation, and the technology is needs less complexity than the BPL. So there are to approach here, and we have decided to use the BPM. So this is the reason that we also decide to use the activity engine in order to also to execute this BPM design. So at the end, what is the challenges of the COMPEL? Well, to scale into the web of service, the Internet of Service, to the crowdsourcing, as it automatically to the BPM and design at the runtime, we will see. So at the end, we can do in the COMPEL. We have automatic discovery. It has an approximate measure making, but also we have included. You can find not only through the ontology, we can also be integrated with the external repository in order to find what are the services that you can use it through the keywords that they can provide. What is the list of the service that this keyword is included in the description? We will see also. Automating word and data flow, we will see also that we can generate all the automatic data that we have it, and dynamic runtime, late binding, rebinding, and so on. We allow this also in the next releases. We want to focus also on these challenges. So COMPEL, the solution. COMPEL is open and multi-platform solution to the business process. In this case, is not included anymore BPL. We are more focused in BPM. We can do this transformation, but at the end, we have decided only to use this standard and not to go more to the BPL by aggregating the offshore-based service. So it is also a part that in next releases we want to also to cover. We want also to cover a service that has been exposing through the REST API, not only web service. For the moment, it's only covered the web service, but our idea is to evolve this to this way also. Processes are designed by business analysts. The process and the tasks are defining using the domain vocabulary we have commented. We try to to reduce this gap between the business and the technical, and the way to do this is through the domains and the vocabulary. For each task, the tool suggests the most matching service that we have it in order to bind this task to this service. The services are located in a centralized repository where the provider register and describe them semantically, so they can expose this service in order to use this domain or this vocabulary and to allow to the business process to find it. We have a coarse grain like semantic for task description. We will see that we can define in the different levels the description of this semantic approach. Domain ontology is based on annotation. It's at an approximate dynamic discovery. We will see. Semantic automatic late binding. We can provide this binding between the task and the web service and the method that we can need to call in order to execute the business process. Automatic data flow generation and executable BPM generation. We will see that we can generate all the necessary code that the technical people need in order to do this, to call to this web service in an automatic way. Registry from process annotation and service description, and at the end execution of the business process through this graphical user interface, and also we expose a REST API through the activity engine. So I think that we can go to the demo. It is the most interesting part. So let me here this one. Okay. So you will see that we have not changed the activity engine brand because our objective is not to change this for the moment. So you can customize this in order to introduce your company and whatever. It is activity is based on Apache of the Apache 2 license, so you can do it. So here you enter in the activity explore, and you can go to the model workspace. So here, as you know, you can define this. You can do this definition of the business process through web service. In our case, I have prepared here to be shorter. We can create this from the scratch, but I think that it is better to go directly. So here it is an example. Okay, this is an example that we can create it. There are only one step. It is a call to the web service. So if we go to the edit, we will see here, this is the part that we have provided in order to allow the binding between the service and the different tasks that we have it. So here you can see this is the BPM 2.out standard, so you can create it here, the different elements that you have it in the BPM. For example, in this case, if we have a service task, imagine that we want to introduce another service task, and this task, you can see here whatever you want, the name, okay. So here we can say, okay, this task, it is related with a web service. I need to find what is the web service that I want to call when this task should be executed. So we can use two methods here. One is the logistic. We can read what is this ontology. For us, is a logistic version 2. We can load it. Now you have here the ontology that you can use in order to find what is the service available for this service. So in this case, we have annotated previously this service through the storage for the functional classification. So you only need to create here functional classification. You will see here that now automatically we have mapped. If you click in another one, you will see that you have also annotated this task with this ontology. So if you click here, is no more appear, but you can also define the business process. So you have different levels in order to annotate this. In our case, we can finish the annotation in order to find what are the services that you have provided here. More results. This one is entity, spatial entity. We have also defined that this is a kind of movable resource in the definition, so we can say that it is the input. So we will receive an input for the functional storage, and the output will be as is available in. Okay, so you can also include it here, the triplet. Okay, and now you can search here in order to find what are the services that you have it. And they say that you have this service that you can see. If you click here, you will see that you have here the WSDL that you have it in order to call this service, and also the method that you have it. The operation is available. This exactly this one. Okay, you can click here and you will be buying this. Okay, so you can also do this through the marketplace. In this case, it is integrated with the marketplace generic enable. If you know the different generic enable that you have it in FIWare, this is one of the generic enable that we are using. But the problem is that this system is down, so I need to check it exactly. But if the instance that software as a service for this marketplace generic enable will be available, here you will see the different services that cover this keyword, and you can also bind what is the method that you need in order to associate this task with this service and this operation. So at the end is the same. The difference is that we can use ontology that you have it in order to find this, or you can be integrated with an external repository, a third party, in order to find what are the services that you need in order to associate to this task. So in this case, the service is down. I need to check it with the people at UPM what is the problem. So it's a pity I cannot show it, but the idea is the same. It is based in the USDL, so you can describe here the web service that you have it, and so on. So it is also a standard. You can use it, and you can bind through this marketplace. So at the end, we have it here. Input, start the business process. We have it here the service that you want to bind with this service. Of course, it is stored in the database. So if we enter again, we will see that this data is stored in the database, and you have also here the bind. So what we need to do now? That's clear that the web service, the WSDL, is defining what is the input and output. We need to map between the different inputs and outputs, and in this case we know what is the name of the attribute in order to call this, and we have saying that here in the for that activity provide, we have mapped it directly with the variable that we will create it in order to call this web service. We can do this when we generated the XML, but if you do this here, because you know it and you are in the design phase, in the technical design phase, you can introduce here, and you will see that you don't need to do nothing in order to deploy this business process in the activity engine. So we will see now. So now you have defined this, you are ready in order to deploy it. So we come back, and now as you see, the business process people can manage this part in the sense that they can find what are the different attributes or the different bindings that we need to know to introduce in order to include it here. They can also include it here, the different steps that you have it in the business process. But what is important that the technical people can identify the different attributes that they need in order to be executable, but also they can see what are the binding that this business process has introduced. But what is important here, they can realize this is a web service, this is the operation that it is binding, and also what is the detail through the WSDL. So now the gap between the business process and the technical people has been reduced. On the other side, when the technical people has provide this definition of the technical business process, they need to generate the file. So this is the export that activity provide in order to be executable. But this BPM that we will see here is not enough to be executable by the engine. Why? Because in this service task there is not more information. Okay, but as we have seen, it is binding in the design phase. So the idea is that now we can export this with the compile export model. So we will see that now automatically we have generated all the data that this business process needs in order to be executable. You can see that the difference is quite enough. Maybe if you only have one service, maybe there are 10 different lines in order to define the method and the attributes that you need to call it. But imagine that you have 40 service tasks and so on. So you can reduce here the number of iterations that you need to do in order to include it here. We are using the standard VPN in order to introduce. You can see here, for example, that the process is here the service task we have binding with the WSDL. There are also here the specification of the input and output, all the interface that you need in order to call this service. So you can see here all the data that you need. For example, here is the WSDL. So you can also import this WSDL in order to be executable. So now we can store this, whatever we want. Here, for example, sorry, it's introduced here. Real demo. Okay. So now you have it here. This sorry. Here in manage you can deploy it. Okay. So we can find the demo, real demo. Okay. So now storage real demo here. You can see here there are now is deployed inside the engine. If you see, we have not introduced more steps between the final definition of the technical design and the deployment of this in the engine, the activity engine. So now you can see here that they generated the image and also the XML that we have seen in the text editor. So at the end, the engine has generated a link that you can go directly to the storage stage. Okay, so you can see now, we will see that now you can initiate the process. Sorry, it's in Spanish. So here we can introduce whatever we want. This is the input that we have introduced in the form in the start task. So you can call it, and they say that okay, started successful. Okay, you will see here that this is all of this demo is in local. So this is a call. It can be in another computer. So you can see here that the web service has received this this input and they return that it is not available. If we introduce here, for example, we can again and we introduce here a correct number. It's a dummy data. So you will see here now the request. If you introduce the correct ID product, they say no, they are available in the factory, whatever. So you can use this in order to include this output in your business process. So this is a very simple example. I would like to now very quickly to show a more complex business process definition. Of course, the idea is not to do this in this demo, but I would like to show you here that you have demo correlation calculation. You will see that this is more complex, okay? And we have it here, an input. We have here a gate that we can do in parallel 3 tasks, and we call 2 different 3 services. The idea is that we need to collect data from the 3 different web services. One is the historical data of the pollution, another for the temperature, and another for the traffic. So they analyze automatically if there are any error, and they can call back and repeat or finish with the error, or they can wait until the 3 tasks, the parallel tasks, will be executed. At the end, the user can or the business can define what is the calculation of the pollution regarding with the different temperatures and the traffic and the pollution. At the end, it is stored directly in a new virtual store. So the data of this output will be stored directly. Well, we create firstly the virtual store, and when it is created, we can store this in the data, in this virtual store, and analyze the results. If it is okay, we finish. If not, we start again this process, okay? So I also want to show you very quickly that we can go to the edit, and we will see here that you maintain all this. Sorry, it's a big diagram. So the idea is that if you click in the different web service, you have here more than one service, and the business people say that the service that you need to use is this service with this operation, not another one. So they choose what are the services that you want to use it. Also here, so you will see here that there are a lot of maintaining binding between the different options that we have it. So also we will see that you can generate automatically this. So you will see here all the data that you have it. So at the end here there are a lot of, we reduce here the work in the sense that we can generate a lot of the code that we needed in order to be executable. So we can go to the instance. This is one. Okay, this is the instance that I want to start it. So we can decide to start the process. So now we will see here there are manual tasks. So at the end I have assigned all the tasks with my user, but you can assign these tasks to the different users. So here you can start the experiment, okay? And we will see now, we can go here and now appear 3 tasks that we need to complete. Okay, the 3 tasks are showed here in the status of in the business process. So you can see here, there is one here, another here, and finally here. So at the end, you need to introduce here all the data that you needed, okay? You will see here, this is the data with introduce here the in data. So we will see now there is an error, okay? So we can go here and see what is the result. In this case, it's an error because the code that I have introduced is not the correct one. It should be 001. So we can repeat. So if we go to the instance, we will see now we have here, sorry, it's this one. We have here an error that you need to be analyzed in order to decide if we repeat or not. We can go back in this case and say repeat. Now appear again because you need to do it. Now disappear. So we are waiting until we finish the 2 rest parallel tasks. So in this case, we can also introduce here the correct one. Disappear, and at the end, the traffic jam, we will see that if we introduce here whatever, we will see that now the error is, sorry, it's, I stop it, sorry. So you will see that you can see here now it's stop it because I not check it the repeat. So at the end, we are in this task and I say yes to finish. So if not, you can see that you can go to the rest of the steps and you can call the different web service. Only to show you here that you have received here the different inputs. If you remember, there is a remote web service that you receive this, and there are the errors that you have it. Okay, for example, in this case, there are an error page data because it's not the correct one. Okay, so you can also differentiate the different errors and so on. More or less that's all.